as much as mesh you make, you are this much close to your answer, you are this much close to your result. So meshing is very important. As it is shown here, for example, you want here obtain real answer, so you need to make here very like strict meshing, very close meshing system, very close system. Otherwise, you will be far from the answer. Anyway, I will not make you so tired. I will pass this. Just I want to show you like number of elements. Let's say in this one is like 33,641 such numbers in this model. Anyway, and then after mesh, you write the material like plastic, homogeneous, and then others that we obtained before. Here we write the materials that we obtained in our experiments. We use these ones, yes, and then we set the connections, like friction connections, non-friction connections, like if it's about like how the material is touching to other one. Like in this one, for example, in reality this is welded, so it should be connected as it's here, surface to surface connection, like how we were saying, like untouching. Okay, something like this. I don't remember right now. And then here it's allowing free space, so everything should be like in reality. Otherwise, you will not get the result. This part is just solving it in manual drawing. Here we set the boundary conditions, and here we gave 150 millimeter of displacement. And then actually these were animations, but we have a little problem about that, so we just see it like this. After giving here the load, it's changing. These are actually this was imagination that this animation that after the load, these bolts have fatigue and then they are destroyed. Just unfortunately now animation doesn't work, so you are not able to see. But these are some real experiments, and we try to make them same to get close with our model. Yes, as it's shown here, separation. Yeah, here I will just tell you shortly about our parametric study. This is what we use all the models that we use. We use this one. Yeah, these are the sections of it. So we use build-up profile in our problem. And this is the experiment that was made with Yongyu Shi, if I pronounce it right. And we tried to get the same results as him and his members to understand our parametric study is right or wrong. And we were very close with the materials different shape, like as here, phi, how it's giving rotation to material, and we compared also like moments, we compared also normal stresses and all that, so we were very close with that one. And this is our parametric study models. As I told you, our main focus is connections. So we made 5 different connection type. Like as it's here is nothing, but it also have more combinations. Like in this one, this part is changing, like thickness of plate. In our coding system, it's like TP0 means this is 12 millimeter, TP1 20, TP2 28, etc. And then diameter of hole, as you see here, is changing various stress of the bolts, and then thickness of column. We made also this part is various to see, dramatically how this part is changing. And then firstly, I will change with this one, type 1. This, as you see here, what's different is this ones. These parts are different from this one. And then these are rigiding members. And then type 2, this one, and here we have gusset. Gusset 300 millimeter, type 3. Again Gusset, again this stiffener, but this time Gusset 200 millimeter, and these others are values are same. It's all changing. And then the final type is again this brigiting and this Gusset just 100 millimeter. So with this all the various, these ones, we obtain this type. How many types we have? 5. TP number is thickness of plate, 3 different. Diameter hole, 3 different. Thickness of column, 2 different. And press stress is 3. Yeah, here is wrong. Here it should be 3. And yes, here I wrote right. And if I multiply all of them, then I get 270 combinations. Yes, I'm at the result part, so it's almost finishing. Like type 0, and then like let's say in this one, type 0, it means this time. TP0, it means 12 millimeter. TC0, it means 12 millimeter of column. As you see here, this coding is for that. DH0, it means 20 millimeter. And in the same manner, we solved our problem in automatic manner. Here I just showed you some, not all, some. And as you see here, different type of changings. And we study on this different type of changing. Like let's say this one is this. And now let's go to type 1. As you see, we are studying this radius of the material and how many distance it gets, how many displacement it gets. This is what we are studying right now. It's not, we didn't end it yet, but we are working on it. Just what is interesting, we are doing this everything, not drawing one by one, but just in automatic manner. In Python language we write and then we get the result. If we just write this, like say, let's say this thickness, 20 millimeter, 30 millimeter, and it's changing all 270 combinations. And then this one, Gusset, and then this, as you see, it's different. Yeah, and then we obtained this three-dimensional graphs. How is it changing? Here it's not shown well. Just like here is like a maximum. Here is S max. It means stress. We see stress, M max moment, and N1 max normal force. And here same again, but for 20 millimeter. 20 millimeter column thickness. Here 12 millimeter column thickness. Different type of reactions to what we get. And you see the difference. Yes. How it means like how much more it's moment taking compared to this. This one it's taking this much moment, but this one is able to get this much moment. Yeah, it's able to show us and let us to have some comments like this. Yes, here are some literature that I used. Thank you for listening.
Arkadaşlar sorunuz var mı?
May I have a question?
Yes, of course.
Thank you very much for your interesting presentation.
Yeah, thank you.
I wonder which type of elements have you used for in the abacus?
Which type of elements we use?
Yeah, must be solid element, but
Yes, we used solid, homogeneous materials we used. Yes, and steel materials, S235,
yeah.
S275 grade materials we used.
How long did it take one of the model to run?
How long? Actually, writing in Python maybe took.
Just for running?
Yeah, just for running.
Yeah.
Just for running took nearly 10 days.
I
Yeah,
think so.
in very powerful computer.
Yeah, because you have done many of the models.
Yes. Yeah, totally 270 combinations.
And you used the true stress strain curve or just you?
For assigning the material, you
Yeah,
mean?
for
No, not just that. Just stress strain graphs we used.
Yeah, you use the stress stream, but
Yes.
to use the true stress stream.
True stress. Yeah, that's a good question actually. True stress is different.
Yeah.
Yeah, we also consider this one. Yes.
Okay.
True stress, traxility, etc. We, as I told you, to get the real answer, we searched so many types of like chemical of the steel. We studied like the real chemical of the steel, because if we don't write in abacus right material, we will not get the right result. That's why we run so many experiments that has been done, and we got similar answers. So we said, okay, our program is working well. Then we made our parametric solutions with other types of connection types that we use. Because in Turkey, in other countries, there are some programs for it, but in Turkey, there are not so many programs that solve and give result with steel connection members. Yeah, we make our analysis in SAP 2000 mostly.
Yeah.
But when we come to the connections, there are some programs, yes, but I believe it's still not enough. My desire is to make some connection program that can be used by civil engineers for make this steel structure buildings to understand and give the best economic, the most economic, the most suitable solution. That's our target.
Yeah. Thank you. Thank you
Yes,
very
very
much.
well.